Hello and welcome back to App for You. In this particular video we are going to discuss a new problem from Heaps, and basically a very simple problem, and basically we have to find the minimum cost of ropes. Now before we proceed, let us first quickly understand what the problem actually says. So the question says that there are given n ropes, means of different lengths. So there are n ropes present and the length of the ropes are different. Okay, we need to basically connect the ropes into one single rope, and the cost to connect two ropes is equal to sum of their lengths. The task is to connect the rope with minimum cost, right? So basically we have to connect the ropes into a single rope by incurring minimum cost, right? Basically we have to just do it at minimum cost as possible. So suppose we have a rope of size 4, 3, 2 and 6. Now there are multiple ways of connecting the rope into a single rope. For example, you may do one thing, that you may just connect 2 and 6 into a single rope of length 8. Now we have 3 and 4 here, right? So cost incurred here is 8 plus. Now suppose I will join these two, then this will become 11. The rope length will become 11, right? How much cost did you spend here? 11 plus. Now if you combine these two, the cost will be total, it will be combined into a single rod of length 15, and the cost will be 15 here. So what is the total cost? So 8 plus 11 is 19, 19 plus 15 is 34, right? So this way there are many ways of connecting this particular rod, right? There are multiple ways of connecting these particular ropes. You may connect 4 and 3 first, that will give you 7. Now you will connect this 7 with this 2, you will get 9, and then 9 with this 6 will be 15. So total cost will be basically 15 plus 9 plus 7, which is again 31. So there are, you see, multiple costs that can be incurred. Now you have to basically merge them into a single rope, and at the same time you must ensure that you are spending as minimum as possible. So if you have studied this algorithms good enough, then I hope you got the idea that this problem is nothing but similar to optimal merge pattern, right? I hope you got it. Optimal merge pattern, right? So basically combining the files, right, by minimum movement. That's simple. That's it. That is what we are going to do. Suppose let me write the examples 4, 3, 2 and 6. Now let me zoom the screen. So we are going to take the help of Heap, right? So Heap, we will call Mr. Heap, and Mr. Heap this time will be basically Max Heap. We will call Mr. Max Heap. Now how will he work? Basically, let us declare Mr. Max Heap, and there is I'm sorry, not Max Heap, because we now see the, let me explain you the question first. So basically we are going to call Mr. Min Heap, right? So how min heap will work? So first of all we will insert all the elements into the min heap, and once we insert all the elements into min heap, what we will get? We will get a min heap. And how will the min heap look like? The smallest element on the top greater than the children, like 2, 3 and 4, and as left as possible 6. This will be the structure of the min heap that will be created after you build a min heap using these elements. So let us first of all declare a min heap. So declaring a min heap is very simple. I hope you understand the code. Priority queue, that's it. And we know that now please pay attention that here everything has been declared as long because they are going to deal with large numbers, like array integers. Array values are also long because the elements of the array are long type, and the number n is also long type. That is why we will be declaring this also long. Okay, and I'll be declaring with int, dealing with int. Fine. Next I'll be saying take vector, not this int, okay, sorry, long int, right? And this will be basically vector long int. Again we have greater long int, right? What will be the name? The name will be heap. Suppose I'm creating a min heap whose name will be heap. Now what we are going to do, we are going to create a min heap. So for creating a min heap, again I'll be using variables long I. Okay, so for time being I'll be saying for I is equal to 0, I less than n, I plus plus. What am I going to do? I'm going to push all the elements into the min heap. So basically a heap dot push what? Array of I. So the elements of this particular array are going to be pushed into a heap, and finally we will find that min heap is created, right? So our min heap is already created by this so far. Once the min heap is created, now we know that as per the optimal merge pattern, what do? We pick up two elements. We take one element number 1, one element number 2. This will be the first smallest element in the heap, the second smallest in the heap. you will combine them into a single and push them back into the heap. So how will it work? Basically we will say, while we are left with only one, now see how this particular problem will work. Basically, suppose I want to combine them into a single value, into a single rope. These are the rope lengths. Okay, I want to combine them into a single rope length of minimum length. What will I do? First of all, I say num1 equal to pop one element from this mean heap. I'll get 2, right? 2 is removed. Now which element do you think will come here? Basically it will arrange itself such that the minimum element is at the top. Again you will say pop one more element, then which element you will get? 3. Now you will say n1 plus n2 is equal to 5. So this is basically a cost right now, cost equal to 5. This is the new length of the rope. You are going to push it back into the heap. So once you push it back into the heap, so basically you will be having this this 3 element, this 3 basically will also be removed, right? Because this is the n2, you have removed this. Now you will push 5 back. So you will have now 4, 5 and 6 new heap, right? Now what we are going to do? Now we are going to say again, since the heap still has 3 elements, right? So again we will say pop 2 elements. So basically I'll pop n1 again equal to 4, n2 is equal to 5, right? So again what will be left? Only 6 will be left. Again you will say n1 plus n2 is equal to what? 9. So you will push this back into the heap. So your heap will consist of 6 and 9, right? The mean heap architecture will be like this: 6, 9. So cost incurred is 5 plus 9 plus. Now this time again you will say n1 again is equal to pop. So 5 will be popped. Next time n2 will be equal to 9. You are doing n1 plus n2, which is nothing but 14, right? So 14 is the cost you added here. Got the point? 14, is it true? Sorry, this is 6, right? This is 6, not 5. This is 6. Sorry. So this is 15. So 15 cost will be added here. What is the total cost? 29. And now you will see finally when you are pushing it back into the heap, your heap has only one element. The moment your heap has only one element, you will conclude that I have successfully combined all the elements of this heap. So what should we do? Basically, see the same thing we are going to write here. So while our heap is not left with only one element, so while our heap dot size is greater than 1, as long as heap dot size is greater than 1, what should I do? I should first of all pick up n1 is equal to heap dot top, right? We should not directly pop. First of all we should do top, because this will give us the value in the top of the heap, that is the minimum element in the top. And now you can basically pop it. So heap dot pop. Again we will repeat this thing. What will you do? We will write n2 equal to heap dot pop and again heap dot pop. Now what should we do? Basically cost, and we have not declared the cost variable here, right? So int long int I comma n1 comma n2 comma cost is equal to 0, right? So what we should do is basically cost plus is equal to n1 plus n2, that the cost is being added. Remember we are adding 2 elements, and now basically we should push it back, right? So basically we should write heap dot push basically n1 heap dot push n1 plus n2, right? So this is how the problem will actually work, wherein we are popping 2 elements, 2 minimum elements, and then adding and then pushing them back, right? So finally the moment when you will be left with only one element, what you should return? You should return the cost. That's it. That will be the answer of the question, right? So let me quickly show you the working. We have 4 3 2 7 4 3 2 6, right? So initially suppose I'll show you the heap. Come on. So 2 3 4 and 6. Initially you have this, you will pop 2 elements. So after removing 2 and 3 and then adding 5, so you will basically have 4 5 and 6. Got the point? How did you get 5? Remember I am popping this also. Next time I will pop this. So basically 3 plus 2 is 5. 5 will be put again back to the heap. Now again you will do, so here n1 was 2, n2 was 3, right? And you added them and pushed into the heap. Now again here in this case your n1 will be equal to 4, n2 will be equal to 5. You will add them and push them back into the heap. So your heap will contain now 6, 9. Again in this case n1 is equal to 6, n2 is equal to 9. You will add them and push them back, so your heap will contain 15. Now your heap has only one element, so you basically stop. What is the total cost? Total cost is cost of merging this 5, cost of merging this 9, and finally cost of merging this, which is 15. So 15 plus 5, 20 plus 9 is equal to 29, and you will return the cost. So let us quickly run this particular code and see how it works. So compiling it. Yeah, the answer is fine, and let me see. Talking about the time complexity, so since we are using a min heap here, so the time complexity basically for building the heap will be order n, right? Building the heap takes order n. And but if you remember these particular operations here, the pop operations, so basically after popping up every element, it will take log n time to adjust, right, back to the heapify basically. So overall time complexity will be order of n for building the heap, plus for this particular step it is order of n, and for this step here it is basically taking n log n, right, order n log n. This is the time complexity. So that's it from this side. I hope this video was helpful. In case of any doubt, please feel free to put it out in the comment section, and just like, share and subscribe. Thank you.